welcome to today's lesson, which is on reverse percentages. So, I'm going to be looking at two different types of reverse percentages today, and two different methods. The first one, which is going to be looking at the bar method to work backwards, and the other one is by using the multipliers and working backwards as well. So, with reverse percentage questions, you're always looking for things which are in the past, so be careful. You're always looking for things which are saying something along the lines of what was it before, or what was it previously, or well, let's have a look at this first case. So 10% of a number is 45. What is the number? So what is the number originally? And understanding that is the starting point of this question. You've got to understand that actually you're not trying to find 10% of 45 in this case. You know that 10% of the number is 45, and that's really important. So let's have a look at the bar method for this case. So this one here is example 1. Remember to make sure you're getting these down in your notes. Remember, the only way to learn maths is to do it. So example 1, 10% of a number is 45. What is the original number? Now we're going to be looking at the bar method for this. So the bar method starts you off with a bar which we know is worth 100%. Okay, it's always worth 100%. So that full bar is worth 100%. Now it's saying here that 10% of a number is 45. So we know that I can split this up into tens. So here we go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're saying that 10% of this is worth 45. So 10% of the original number is worth 45. So what's the original number? So if we know that 10% of the number is worth 45, then what we're trying to do is you're always trying to find the original amount. Now, it's worth noting that the original amount is worth 100%. In fact, it's worth probably getting that in your notes. The original amount is worth 100%. So, in this case here, it's saying that 10% of an amount is 45. What's the original amount? So we're trying to find this 100%. And we can do that by, well, you can either fill all of these in, because I know that each of these are worth 10%. There's 10 of them. And they're also worth 45 each. So all of these are worth 10%. Okay, 10%, 10%, 10%. Okay, so if I know that 10% of a number is 45 and it's split into 10 parts, we want 10 lots of this 45, so it's going to be 45 times by 10, which in this case is equal to 450. So that's the first reverse percentage question. So what I'm going to say now is pause now and have a go at that one yourself. So have a go at that one on the right. I'm going to go through it in a second if you're not too sure. Okay, so let's have a go at this one together then. So, example 2 this is. You should have got this one down anyway when you had a little go at it. So, 20% of a number is 86. What is that number? Now, again, we're going to be looking at the bar method. Remember, we're trying to find 100%, which is all of this. 100%. And this time it's telling me that 20% is worth 86. What was the original amount? Okay, what was the number that was found of this? Well, if we know 20% was 86, well, how many times does 20 actually go into 100? Well, 20 goes in 20, 40, 60, 80, 100. It goes in 5 times. So I can split my bar up into 1, 2, 3, 4, 5. And this would be, all of these would be worth 20%. So what do I need to times 86 by to get back to 100%? Well, if it's 86, there's going to be 86 in all of these. So it's 86, 86, 86, 86, 86 5 times. Or you can just do 86 times by 5, because there's 5 of them. In which case it's going to be 6 times by 5, which is 0 and 3, 30. 5 times by 8, which is equal to 40. And the 3 is equal to 430. Okay, so with that one there, we knew that 20% was worth 86, so to get back to 100%, I've got to times by 5, which will give me 340. So let's just, 430. So let's check both of those answers. Brilliant, 450 and 330. Super. So that's the starting point of this, is when you know a particular percentage of something and you're trying to get back to 100%. So let's have a look at the next type of this. So, a price is decreased by 10% and is now 396. Work out the original price. So, with this one here, it's a little bit different. Now, these do come up on non-calculator papers, okay, which is why I'm going to be using the bar method so you understand the technique. So, this one here is example 3. Again, make sure you're getting it down in your notes. The only way to learn maths is to do it, okay? So, first of all, let's draw my bar. And I know that this bar is worth how much? 100%. Brilliant. Okay. So the price is decreased by 10%. Work out this now. Now, I'll tell you the mistake that people always make with this. When everybody's first doing this, they find 10% of 396 and then add it back on. But you can't do that, and let me show you why. Okay, so a price is decreased by 10%. So first of all, I'm going to split all these up into 10%. So halve it and then do 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? And each one of these is worth 10%. Okay? Every single one of these is worth 10%. Let's put them all in just so you can see it nice and clearly. You don't have to do this every time, but with this one I'm going to. Okay, so we've got 100% and it's split up into these 10%. So a price is decreased by 10%. Okay, so what we're saying here is this has been reduced by 10%. So I'm getting rid of this one here. And it's telling you that this is now worth 396. So what we're saying is that all of these together, so every single one of these here, is worth 396. Okay, so it's been reduced by 10% and it's worth 396. Work out the original price. So, with this one here, to do a non-calculator way, the first thing you've got to spot is that this is worth 90% because it's been reduced. So if it's been reduced by 10%, it means that this is worth 90%. So your starting point is that 90% is equal to 396. So all of these here are worth 396. And this is because it's been reduced. So I've taken away 10%. Okay? If I take 10% away from 100, I end up with this 90% here. And this is worth the 396. So there's my starting point. 90 is equal to 396. So work out the original price. So you're not dividing this by 10 because that's what people do. What we need to divide by here is divide by 9 to find 10%. And that's what makes this trickier because actually I've got 9 of these which is worth this much. So to find out 10%, I need to divide by 9. So divide by 9, divide by 9. 90 divided by 9 is 10%, which makes sense. 9 of these divided by 9 is 10%. And then I need to do this divided by 9. So let's do that on the side, because remember this is a non-calculator. 3, 9, 6. So how many times does 9 go into 3? It doesn't. How many times does 9 go into 39? Well, it's going to be 9, 18, 27. So it goes in 3 times 27, silly Billy, 9, 18, 27, 36. It goes in 4 times with 3 left over, okay? And then it goes in 9, 18, 27, 36 again. So it actually goes in 44 times. So here, 10% is worth 44. So what we're saying now is if 9 of these are worth 396, each one of these is worth 44. Okay, so that's worth £44 each. So we're using this bar method to visualise how much each of these are worth. So each of these are now worth 44. So in which case, how do I get back to 100%? Well, if one of these is worth 44, and that's 10%, then I need to times this by 10, okay, to find out 10 of these, which is 100%. And I can do that here as well. So I'm timesing by 10 and timesing by 10. So 10% times by 10 is equal to 100%, which makes sense. And 44 times by 10 is £440. And that's that question done. Brilliant. So what I'm going to say is pause now and have a little go at this next one. Okay, have a go at that one on the right. It's very, very similar. We'll go through it in a second. Okay, let's have a little look at this one together. This one here is example 4. Example 4. Super. So we're going to use our bar method again. And it's exactly the same as the last one, isn't it, really? It's just different numbers. So a price is decreased by 10%. So if I'm splitting it up into 10%, so I need 5, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's been reduced by 10%, so I need to get rid of one of these 10%. Okay? And I know it's now worth 225. So I'm saying that all of these, so all of this, let's use the red pen, all of this is 225. Now, how many 10% have I got there? Well, I've only got 1, 2, 3, 4, 5, 6, 7, 8, 9. So my starting point, remember the full part is 100%. Each of these is worth 10% each. Okay, so we've got 90% is worth 225, so let's start with that. So 90% is equal to 225. So in which case, how do I find 10%? Well, to find 10%, I divide by the 9 here that I've got. So divided by 9, divided by 9, 90 divided by 9 is 10, 225 divided by 9, let's do that on the side, so 9 into 225. 9 into 2 goes 0. 9 into 22 goes 9, 18 twice. Carry the 4. 9 into 45 goes 5 times. So here we've got 10% is equal to 25. Okay, not finished there. Remember, I'm always trying to get back to 100% because each of these is worth 10%. And now I know that each one of these is actually worth 25. 25, 25, 25. All of these are worth 25. So how do I get back to 100%? Well, to get back to 100%, I know there's 10 in total to get to 100%. So I'm timesing by 10, timesing by 10, timesing by 10. So 100% is equal to 250. Notice, okay? Let me just show you something here. Now, remember, I said to you, a lot of people, when they do this, if they see it as a 10% decrease, they find 10% of this and then add that back on. But let me show you why that doesn't work. So if I was to find 10%, now remember this is wrong, I'm just going to make it really clear that this is wrong, but this is what people always do. They find 10% of 225, so 225 divided by 10 is 10%, which would be equal to £22.50. So then with that, I'd add that back on, so it's 225 plus £22.50, which mean we can do it here. Let's do it. So that's 7, 4, and this just isn't right because it's 250. I'm £2.50 off, okay, which is a massive amount to be off. Now the reason that that doesn't work is because what you're doing is you're finding 10% of the 90%, okay, which you can't do. So all of this is wrong, okay. So what you've got to do is use this method where we're starting with 90%, then finding 10% by dividing by 9. Okay, brilliant. So hopefully you got that one right. So let's have a just check of those questions. So 440, brilliant. 250, brilliant. So let's have a look at our next ones. So a vase is reduced in a sale by 20% to £56. What was the original cost of the vase? So I think we should be able to do this one as well. I think we should be fine with this. If you do want to pause and have a go at this one yourself, do. If not, I'm going to go through it now. So first of all, we've got our example 5. So we draw our bar out. Remember, we're doing this non-calculator methods, okay? And the vase was reduced by 20%. So let's break it up. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've split it up into 10%. Okay, all of these are worth 10%. Remember, the total is worth 100%. So it's in a sale, it's been reduced by 20%. So if I've been reduced by 20%, I'm getting rid of 2 of these bars here. I'm getting rid of 2 10% because I've been reduced by 10%. Sorry, by 20%, which is 2/10. And it's saying it's now worth 56. So I know that all of this here is worth £56. Okay? What was the original cost? So remember, we're trying to find 100% here. So I know that 80%, 1, 2, 3, 4, 5, 6, 7, 8, 80% is equal to £56. How do I find out 10%? Well, to find out 10%, I'm going to divide this by how many of these? 1, 2, 3, 4, 5, 6, 7, 8. So divided by 8, divided by 8. So 10% is equal to, this divided by 8, well, 8, 16, 24, 32, 40, 48, 56. So that is 7. Okay, so it goes into it 7 times. And then get to go back to the original amount, I need to, well, if I know now that 10% is equal to 7, so each of these are worth 7, aren't they? Even these ones here that we've crossed out. So to find out all of them, so 10 of them, I need to times that by 10. So times by 10, times by 10, I end up with 100%, which is equal to £70. Brilliant. Okay, so these are reverse percentages. Now, I'm just going to point out here, what we've got to be looking for is we've got to be looking for the past tense. So a vase is reduced in a sale by 20%. What was the original amount, or what was the original cost of the vase? It's not saying it's been reduced by 20%, reduce it by 20%. It's saying what was it before, and that's really important. So pause now and have a little go at that one on the right hand side. Okay, I will go through it in a second. So pause now and have a little go at that one using the bar method. Okay, let's go through it together then. So this one here is example 6. So example 6. So a store sign says all items 30% off. I buy a knitted scarf for £4.90. What was the original price? So let's draw our bar first of all. Here's our bar. We know that that's worth 100%. This is worth 100%. We'll split it up into 10%. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each of these are worth 10%. We've been reduced by 30%. So if I reduce by 30%, I need to get rid of the 3 10% here. So I'm getting rid of, remember, each of these are worth 10. So I'm getting rid of this one here, this one here, this one here. Good. And it says that the scarf is worth now £4.90. So it's saying worth, all of these are worth £4.90. Brilliant. Okay. So what we're saying here is my starting point is that 1, 2, 3, 4, 5, 6, 7, 70% is equal to £4.90. So what have I got to do first? I've got to first of all find 10%. So to find 10%, I know that 7 of these are worth £4.90. To find 10%, I need to divide by 7. Okay, not divide by 10. Okay, 70% is £4.90. So divide by 7, which is going to be equal to 70p. So I'll show you that on the side if you want. So how many times does 7 go into £4.90? Well, how many times does 4 go into, 7 go into 4? It doesn't. carry the 4. How many times does 7 go into 49? It goes in 7. I've lost track of myself. 7, 14, 21, 28, 35, 42, 49. So it goes in 7 times. So how many times does 7 go into 0? None. So it goes in and it is 70p. So what we're saying here is that each one of these is worth 70p. So 70p, 70p, all of these are worth 70p. So then how do I find out the original amount? Well, I'm going to times it by 10, because each of these are worth 70p and there's 10 of them. So 10% times by 10 is equal to 100%, and 10 times by 70p is equal to £7, like so. So the original amount was £7. Super. So at the moment, we've only been looking at reverse percentage decreases. Now we're going to be looking at the other way around. So we're going to be looking at an increase. So let's just check 70 and £7. Brilliant. All the 7s. So this one's a little bit different now. So this one here says, in a town of Orphalton, when the sales are on, the sign displays show 30% more expensive today. So strange time, strange offers. But the coat on that day costs £117. Was the original price... what was the original cheaper price? So what this is saying here is that a coat, has been increased in value. So they're saying it's worth 30% more this time, and that's worth 117. So what was the original cheaper price? So this one here is tricky. Okay, so my starting point here. So this is example. This one here is example 7. Now remember, we said we've got our bar, and what's that bar worth? Well, this bar is worth 100%. We know that, okay? The bar's always worth, one full bar is worth 100%. However, with this one here, it says that it's increased by 30%. So what I need to do is add on here 1, 2, 3 10%, which means that it's going to be 130%. Okay, so we can still split this up if you want. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 130. And it's saying that all of this is when it's been increased is £117. Okay, so the coat is increased in value and it's now worth £117. So we're not saying that it's been decreased, it's not 70%, I'm increasing here. So my starting point with this is the fact that 130% is equal to £117. Okay, that's my starting point. So how do I then find 10%? Well, if I know that 13 of these is worth 117, then to find one of these, which I know is 10% each, remember, each one of these is worth 10%. Then I divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm dividing each side by 13, and that's why this is a little bit harder, because it's a bigger number, it's bigger than 10. We can do it. 13 divided by 130 divided by 13 we know is 10%, okay? That's what we've seen. Each one of these is worth 10%. And now this is the tricky one. So 117 divided by 13, what is that? So it's probably best. The only way you can really do this one is if you know your 13 times tables. So let's do it on the side. 13, 26, 39, and then it's going to be 13 plus that is 40, 52, and then 65, and then 78, 91, Now this is tough. This is really tough, the 13 times table. You might just know it off the top of your head. 114. I'm thinking about this one here. 104, and then 117, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it goes in 9 times. Okay, nothing wrong with writing that on the side if you need it. Okay, just make sure you're taking your time with it. So I know that 10% is equal to 9 because I've divided this by 13. Okay, notice I didn't use my calculator for that. This is non-calculator. So then to find 100%, if I know that each of these are worth 9 now, which makes sense because 9 times by 13 is 117. Then to find out my original value, I know that I'm trying to find 100%. And I do that by timesing by, what do I need to times by? Well, I need to times by 10 in this case. So 10% times by 10 is 100%. 9 times by 10 is equal to £90. Brilliant. So that one there was an example of percentage increase. Reverse percentages. Again, notice with this one it says, what was the original cheaper price? What was it before? We're looking at the past tense here. Okay, so let's have a little look at that. £90, brilliant. So Jules buys a washing machine at 20% is added to the price of the washing machine. Jules then has to pay a total of £600. What is the price of the washing machine without any VAT added? So this is another percentage increase. I'm going to make this big, and I want you to have a little go at this one yourself. So pause now and have a little go at that. Okay, let's have a little look at this one together then. So this one here is example 8. Now it's saying here that the washing machine has had 20% added on. So let's start with our bar. You might be able to ditch the bar soon and do it without the bar if you do understand. But for now, I want to do a visual representation. So I know that this is worth 100%. And I'm saying that I've had 20% added on. So in this case here, I've got another 10% and another 10% there. So let's split this up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the extra 20%. Okay, so 20% added on there. And it's saying that the washing machine is worth £600. So all of this here is worth £600. Okay, because I've been increased by 20%. So if I know that here, what we're starting with here, we're starting with 120% is equal to 600. So 120% is equal to £600. Remember, I'm trying to find the original amount. I'm trying to find 100%. So to find, if I know that 12 of these are worth 600, to find one of them, I need to divide by 12. Divide by 12. 120 divided by 12 is equal to 10%. That's the point. 600 divided by 12 is equal to, well, we can do it on the side if we wanted to. You might be able to do that in your head. So 12 into 600. Well, 12 into 6 doesn't go. 12 into 60 goes 5 times. 12 into 0 goes 0. So 10% is equal to 50. Remember, we were trying to find 100%. So I'm doing now times by 10, times by 10. Because remember, what we're saying now is that each of these are worth 50. Let's make it really clear. Remember, because 50 times by 12 is equal to 600, but I don't want 120%. I need 100%, the original amount. So I times by 10, which is 100%, which is equal to £500. Brilliant. Let's just check that. Now notice this was 2 marks, so this one came up in a past paper. This one has come up before, so £500, brilliant. So let's move on. Now I've had a look at these ones because they're a little bit trickier, but these ones actually came from a calculator paper, and actually there's an easier way to do these ones. If you've got a calculator, I would suggest using this method because it is much quicker than using the bar method, but these ones here were all non-calculator techniques. Okay, so example 9, let's make it big so you can get it in your book. Remember to get your notes down. Remember the only way to learn maths is to do it. So this one here is example 9. A number is increased by 35%. The result is equal to 324. Work out the number. So I'm going to draw the bar just so you can see the starting point. So number is increased by 35%. So this here is my 100%, always. I've increased by 35%. So instead of breaking up this time, I'm just going to add on this here, and I say that this is equal to 35%. And now what I'm saying here is that the result, so all of this is equal to 324. Now, I'm just going to take a step back a little second here, because there is a little trick that we can use using the multiplier. So looking at this one here, I know that I wanted to get to 500, so I could have with this one, if I'm using the calculator method, here's my starting point, 120 is equal to 600. Now, there's a very quick way to get to 100%. So how do I get to 100% quickly? Now, the way you do that is you divide by this as a multiplier. Okay, so 120% as a multiplier. Well, what is a multiplier? Now, you should have seen that video. If you haven't, make sure you go back and you watch it. A multiplier is when we write this as a decimal. So we know that 120% is equal to 120 out of 100, which is equal to 1.2. And the quick way to do this is to divide both sides by that multiplier. So divide it by 1.2 and divide it by 1.2. So if I divide by my multiplier, this becomes really easy. And I'll just show you that. So here we've got 600 divided by 1.2 gives me 500. So straight back to there. So if we divide by my multiplier, it's much easier. So let's have a look at that then. So with this one here, we know that 135% is equal to 324. So that's my starting point. 135% is equal to 324. Now remember, I'm trying to get back to 100%. And to do that, I need to write down what my multiplier is first. So to work out my multiplier, it's going to be 135 divided by 100, which is equal to 1.35. Remember, if I was to times by that, I'd have an increase of 35%. But I'm not trying to find out my new amount, I'm trying to find out my original amount, and I do that by dividing by this multiplier. So divide by your multiplier, which in this case is equal to 1.35, divide by 1.35. So you can even do it in your calculator if you want. So 135 divided by 1.35, that's going to give me 100%, and that's the point. So this here is 100%, which is what I want, and I've got to divide this side by 1.35 as well. So 325 divided by 1.35, let's get that in. In this case, no, it's pretty nasty. 324 it is. 324 divided by 1.35, which is equal to 240. So this one here was 240. And notice how much quicker that is. So I just find out my multiplier and then divide by it, okay? So that there was example 9. In fact, if you want to pause and have a little go at this one yourself, the next one you can do. The shop had a sale and all prices were reduced by 15%. A pair of shoes cost £38.25 in the sale. What was the price before the sale? Okay, so I am going to start with our bar method just so you can see how much we've got. So this here is example 10. So it says it's been reduced by 15%. Now remember, my bar is always worth 100%. If I've been reduced by 15% and taken away 15% there, so this is 15%, which means that this here is now worth 85%. Okay, 85% and the 15%. And it's telling me that the pair of shoes now costs £38.25. So it's saying that 85% here is worth the £38.25. So 85% is worth that. That's my starting point. My 85% is equal to £38.25. So after reduction, after I've taken away 15%, it's now worth 38.25. So that's worth the 85% there. Let's write down what my 85% is a multiplier. So that's going to be 85 divided by 100. Remember, percent means out of 100. So 85 divided by 100, which is equal to 0.85. So to get back to 100%, I'm dividing by 0.85. Dividing by 0.85. 85 divided by 0.85 is equal to 100%. That's the point. And this one here, £38.25 divided by 0.85, in this case, is equal to £45. So if you know what your multiplier is after it's changed, so in this case reduced by 15%, we can just divide by that if it's a reverse percentage question. Notice with this one again, it says, what was the price of shoes before the sale? Okay, what was it before that it happened? Okay, all right. So we've looked at the non-calculator methods. We've looked at a percentage multiplier method. So let's have a look now at some other questions. Okay, so these two questions here look very similar to the ones we did before, but they are very different, okay? Now, these ones come up on the higher paper towards the end. Now, I've actually seen these come up on several times recently in the Excel paper, and they always trick people out. They are a reverse percentage question, however, they're giving you something different, and that's really important. So, let me take this one slowly. I will give you a chance to have a go at that one on the right yourself, okay? So, in a sale, all normal prices are reduced by 20%. In the sale, the normal price of a tablet is reduced by €79. Work out the normal price of the tablet computer. So, I am going to draw out my bar with this because I think it will help us, okay? So we've got our bar. Remember to make sure you're getting this down in your notes. The only way to learn maths is to do it. I'll keep hammering that. So I've got 100% here. Now, it says, in a sale, all normal prices are reduced by 20%. So I know that I'm being reduced by 20%. So I'm taking away 20%. So I'm getting rid of two 20%. Okay? Sorry, I'm getting rid of two 10%. So this is 10% and this is 10%. Okay? Now, it doesn't say the computer's now worth £79. It says it was reduced by €79. So what it's saying here is it's not saying that this part here is €79. It's saying that the reduction is worth €79. Okay, so this part is worth €79, and that's why this is tricky. And remember, you've got to be able to differentiate between these. Do you understand the difference between it saying that the price is now €79 or it's been reduced by €79? They're very different things, and those subtle differences make this very difficult to spot. Okay, so it's been reduced by £79 and it's been reduced by 20%. Work out the original value of the computer. Now we're still trying to get to 100%. However, my starting point here is that 20% is equal to €79. Okay, 20% is worth €79. Now, I'm going to use the multiplier method again for this. How do I get back to 100%? Well, I write down this as a multiplier, which is going to be 20 divided by 100, which is equal to 0.2. So if I divide both of these by 0.2, it will get me back to 100%. Now you could spot here, there is another way to do it. We could, to get back to 100%, we could halve 79, which would give me 10%, and then times by 10 to get back to 100%. I'm just using calculator methods. You don't have to use this technique. You could have found 10% and then times by 10. So with this one here, 20% divided by 0.2 is equal to 100%. That's the point. We're trying to get back to 100%, which is our original amount. And then 79 divided by 0.2 is equal to €395. Very, very subtly different. Okay, it's saying what the reduction's worth, not what the new price is. Okay, so have a little go at that question on the right. Okay, pause now and have a little go at that one yourself. Okay, so let's have a go at this together. Example 12. So in a sale, normal prices are reduced by 17%. The normal price of a washing machine is reduced by £42.50. Now notice that it's saying that it's reduced by that amount. So the starting point is that 17% is equal to that. It's not saying it's worth that amount, it's saying it's reduced by that amount. So let's just see what that looks like in my bar method. So I know that this is worth 100%. I've been reduced by 17%. So this here is being reduced by 17%. And I know that that reduction is worth £42.50. So my starting point here is that I know 17% is equal to £42.50. Okay? So to get back to 100%, I'm divided by this as a multiplier, which is 17 over 100, which is equal to 0.17. So divided by 0.17, divided by 0.17, so that's going to be 100%, which is equal to £42.50, divided by 0.17, which is equal to £250. Notice, you wouldn't have got that if you hadn't have done it like that. That's pretty much the only way you would have got that. You can't find 17% of this and add it back on. You've got to use reverse percentage methods. So that one there is example 12. Now there are two more examples to have a go at. I know this is quite a long one today, but this is quite a tricky topic and all of these questions usually come up. Okay, so this one here is pretty easy. You might want to pause and have a go at this one. It's not massively easy because there's more than one step. It is a progression, but I think you should be able to do this if you're feeling quite confident. Naomi is given a 10% decrease. Her new wage is equal to $252 per week. What would her weekly wage have been instead if she'd received a 10% increase? Notice this is worth 5 marks. This is a question that has come up. This was on an Excel paper I actually got this from. So this is a question that has come up before. So this one here is example 12. No, sorry, example 13. So Naomi was given a 10% decrease and this is worth 252. So let's draw there's our bar. We know that a bar is worth 100%. If she's had a 10% reduction, I know I'm reducing by 10%. So I'm getting rid of 10%. And her wage is now worth 252. Now notice it's saying that her wage is worth that amount. It's not saying it's been reduced by 252. It's saying her wage is worth this much. So what we're saying here is that this amount here is £252. And remember that if it's 100% take away 10%, this is worth 90%. So that's your starting point. 90% is equal to 252. Now this one could actually come up on a non-calculator, couldn't it? Because what we need to do here is we need to find 10% and then add it on to get 100% and then add it on again to get, because it's just saying what does she get if he gets a 10% increase. So I'm going to do this non-calculator methods actually. So to find 10%, I would divide this by 9, divide by 9, divide by 9. So 9 into 252. So 9 into 2 doesn't go. 9 into 25, so 9, 18. So it goes in twice. Carry the 7. Okay. And 9 into 71 goes 8 times. So the answer here, 90 divided by 9 is equal to 10%. 252 divided by 9 is equal to £28. Now there's two ways you can do this. You can either times by 10 here to get 100% and then add that 10% back on, or you can add it to this twice, and you choose whichever method you want to do. I'm going to times it by 10 and then add it on. So times by 10, I get 100%, which is equal to 280. So you probably get, up to this point, you'd probably be getting about 3 marks. Then you're going to get another mark for adding on 10%, and you're going to get a mark for that final answer as well. So 100% is worth 280. But it's saying what does she receive if she receives a 10% increase? So if I want 10% increase, it's going to be 100% plus 10%, which in this case is equal to 280 plus 28, which is equal to 110%, which makes sense, which is equal to £308. Brilliant. 5 marks that. Okay, it's a reverse percentage question and a percentage increase question. So £308, brilliant. Okay, last question before we go on to some trickier ones. So Simon invested an amount of money in his savings account at 0.5% per annum compound interest. At the end of the 3rd year, the amount of money in the savings account was that much there. So £12,180.90p. Work out how much Simon invested in his savings account. So this is again another reverse percentage question, and it comes up all the time. Now what we've got to think about here is we're doing a compound interest. Okay. Now what was the formula for compound interest? How did we do it? Well, for compound interest, the way we did it was, just checking, that was example 13, example 14, last example. I know this one's quite long. For compound interest, we did the new amount was equal to my original amount times by my multiplier to the power of n, which is the number of years. So what I'm going to do here is I'm going to fill in everything I know and then work backwards. So if he invested in his savings account and he got a 0.5% per annum compound interest, he's getting an increase of that. So the first thing I need to do is work out what my multiplier is. So it's going to be 100% plus this 0.5%, which is equal to 100.5%. As a multiplier, I divide that by 100, which is going to be equal to 1.005. That there's my multiplier. Now I can substitute everything in. So my new amount, which is what I actually know, so I know that this is equal to 12,180.90 is equal to my original amount, which I don't know. So my original amount times by my multiplier, which in this case is 1.005 to the power of the number of years, which in this case is 3. So if I'm trying to find out my original value, I've got to do my new value, very similar, divided by this, divided by my multiplier to the power of the number of years. So it's going to be divide by 1.005 to the power of 3, which will get rid of that, and I'm dividing this side by 1.005 to the power of 3. So to find out my original value, I'm doing 12,180.90 divided by 1.005 to the power of 3. And that's equal to, now let's do rounding it to, I'll show you, not a very nice decimal, but what we notice is that it's 99 there. So all of these are actually going to round up. So it's going to be £12,000. So 12,000.00.00 is going to be equal to my original value. Okay, a lot to take in there. Okay, so but all of these questions are coming up, and that's the important thing. They are tricky. Okay, so let's just check that answer. Brilliant. So we've got some questions here to have a go at. So it was a little bit longer today. Maybe so pause now and have a go at these questions. 15 questions for you to have a go at. All very slightly different though, so make sure you're taking your time. Super, so hopefully you've had a go at those, because remember the only way to learn maths is to do it. So mark those in green for me. Super, so thank you for watching this video on reverse percentages. You'll see that reverse percentages is actually a large topic and there's loads of questions, and to be honest, these are the majority of questions that come up in GCSE. So make sure you are paying attention on them. So thank you for watching this video. Make sure you are having a go at these questions, because remember the only way to learn maths is to do it, and have a lovely day.